All right, welcome to the 11A Day 1 notes. Today we're going to cover how to use radians and degrees and how to work with angles using this graph, which we're going to call a unit circle. And we'll get more detailed into that later. But we're going to start with some basics. So as we know, there are 4 quadrants on a graph, right? The 4 different parts on a graph. And if you don't recall, these quadrants have numbers, right? So the quadrant over here is quadrant 1, right? Where everything is positive. Over here we have quadrant 2, and then we just go counterclockwise. So 3 and 4, all right? It's like a C. That's how I think of it. Whatever works for you, you do need to know the quadrants. Probably learned this in 8th or 7th grade, right? All right, and from here, what we're going to do is we're going to look at angles, all right? And so for this is where we start our angles right here, all right? And then this is like 90 degrees, 180 degrees, right? Halfway around a circle, 270, and then 360. And 360 is a full circle, right? So that's also equal to 0 degrees. You're in the same place. And the angles we're going to measure are like from here to here to here to here to here, right? And this is our starting area. So in this case, we're going to do 210, right? So we start here and we go around, around, around. We get to 180. We know it's more than 180, but less than 270. So we're going to say it's somewhere around here, right? And that's angle A. And we know the quadrant that it's in is in quadrant 3, right? Because that's the area of the graph that it's in. So we would write quadrant 3 here, all right? And the same thing for 55. So for 55, again, we start at 0, we go up, 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 right? We don't want to go to 90. We want to be somewhere in between 0 and 90, right? Probably a little bit higher than the middle. So there's B, right? And that would be in quadrant 1, right? Because it's in the first quadrant where everything is positive. So you could write it, you don't need to use Roman numerals. You could just write it like that, right? Or if you wanted to do 185, right? So let's go over here, right? We're going to start at 0, go all the way around, right? A little bit more than 180, not too much, but enough, right? That it's in quadrant 3, right? All right, because if it was 180, it wouldn't be in a quadrant, but because it's a little bit lower, it's in quadrant 3, right? So we could just write 3, right? Just write the Roman numeral 3, all right? Or for 295, just go around the circle, we get to 270, right? Move a little bit farther, and here we are at 295. And we know that that is quadrant 4, right? So D is in quadrant 4, right? So again, you can write it out. You totally do not have to. This would probably be a multiple choice question, right? Because there's only 4 options. All right. And especially with remote learning, makes it easier for me to grade. Okay? Quick, I would pause the video here and try this on your own if you haven't gotten a chance to. All right, so to convert to radians, we are actually going to pull up the calculator that you can see here on the left-hand side. And we're going to use this in a second as a simpler way to simplify our fractions. But I'm getting ahead of myself. Before we get to that, let's first look at this equation right here. So we have these things called radians, right? And radians and degrees are 2 different ways to measure angles, just like we have Celsius and Fahrenheit as ways to measure temperature, right? And so in order to change the following degrees to radians, all we're going to use is this equation, right? And just be careful, we are going to leave the pi in there, so don't end up with a decimal or anything like that, okay? All right, so first thing, right, 210, right? That's the number of degrees, right? So we're going to plug into our equation, and our equation in this case is radians, right? And equals, we're going to plug in the number of degrees, and then do times pi over 180, okay? And so the number of degrees in this case, if we went back up to our problem, is 210, right? So that's what we're going to put right here. So if you wanted to do this by hand, I'm going to show you by hand first and then with the calculator. So by hand, we know that both of these have zeros on the end, so if we divide by 10 on both of them, we can cancel those out, right? And we know that 21 and 18, which is what we're left with, they can both be divided by 3, right? So 3 goes into 21 7 times, and 3 goes into 18 6 times, all right? So if I rewrite that, I'm left with 7 pi, right? Because when we multiply, we just merge these two, over 6. And then because we're looking for something in radians, our units are going to be radians. Or we could write RAD per radian. That's a simpler way to do it. So radians are RAD, just like degrees are usually used with this, right? So let's say you're bad at simplifying fractions, or you want to double check your work, right? Always a good move. You're going to go over to this kind of calculator, all right? And you're just going to plug in that fraction we wrote. So it would be important that you write down this fraction to show your work, but from here you could just plug it into a calculator. Oh, sorry. So what you want to do is you're going to hit F2, all right? Well, maybe. There we go. And then you're going to go down to prop fraction. And the easiest way to get that is to click 7, all right? And that's going to actually give you the answer in fraction form, which is what you want, okay? And then from here, you're just going to plug in the stuff from our equation, right? So 210, the original, right? Times pi. So see how the pi is blue here? That means we're going to hit the second first because that's blue in order to get the pi. All right. And then divide by 180. And make sure you use that closing parentheses. You need this extra parentheses on the end, otherwise it'll give you an error. Okay. And there you go. There's our answer. It's the same thing that we got, right? So this is a great way to check your work. Or if you just really didn't feel like simplifying fractions by hand that day, you could just do this on a calculator. All right, so for here, we're going to say this is equal to, right? We're going to say radians equals degrees. The degrees is 60 degrees, right? We're just going to plug that in. All right. Times, bring over the rest of our formula, right? And then from here, we're just going to simplify, right? Again, you can do this on a calculator. I'll show you that in a second. But you can also do this by hand. Divide them both by 10, gets rid of the zeros. 6 and 18, we know if we divide them both, we get 1 and 3, right? And then 1 times pi is just pi. So it's just pi over 3. Don't forget your units, which are radians. Okay? And again, if you wanted to do that on a calculator, you'd go to F2, right? Maybe. All right, there we go. All right, and then 7, that's going to give you your prop fraction. All right, 60, and then times pi, remember a second, and then up to get to pi, divide by 180, close your parentheses, hit enter, and there you go, pi over 3, just like what we got, right? Super, super straightforward. Let's go ahead and start doing them on your own, and you can just skip ahead and double check your work, okay? Here we're doing the opposite, right? The inverted. This time you see that even our formula is inverted. So instead of pi over 180, it's 180 over pi. But the idea here is we know that degrees are never going to have pi in the answer. So we're dividing by pi to take away the pi, all right? And that's a really good way to double check your work. If you're doing something and it should be in degrees and you end up with pi in your answer, you're probably doing something wrong, okay? So again, it's the same thing with plugging in our equation, right? Here we have what we have in radians. We're going to multiply by 180 over pi, right? And if you wanted to do this by hand, which again, I'm not saying you have to by any means, only if you want to, all right? We know that a pi on the top and the pi on the bottom, they can be canceled out, right? All right, we know that we can simplify this 6 and this 180, right? To be 6 goes into 180, 3, 30 times, right? So I'd be left with, these are all canceled out. All I'm left with on top is 5 times 30. And that we know is 5 times 3 is 15. Bring down the 0. Then do not forget that this is in degrees, right? So we need that degree sign. Units are super important. It lets me know that you know what you're doing and you're not just using a formula. You're also kind of understanding the rest of the process, right? So again, from here, times 180 over pi, right? Okay. As always, right? That's why we divide by pi, so these pi's get canceled out, right? And then over here, we wanted to do this by hand. 4 goes into 180. How many times does it go into 180? We could always use calculator like normal. Here you go. Get 45. Right. So we're left with 5 times 45, which is 225, right? All right. And right, again, I just used a calculator. Not that there's any reason to, right? But you can also use a calculator in the sense that we were doing earlier, right? So again, F2, right? If it pops up. Sometimes it's a little picky. Just move your mouse around a little bit on the button, okay? And then 7 to get to prop fraction. All right, and from here, you're just going to type in your answer. So 5 pi, right, over 4 times 180 divided by pi, right? And again, pi is second up, all right? And from here, close your parentheses, hit enter. It's gonna look a little wonky up here, but it does give you the right answer, right? It just formats it a little bit differently, and that's okay. All right, you still get the right answer. Okay, so you can plug it in just like that. All right. So again, with C, it's going to be the same thing, just this over and over again. Go ahead and run through these really, really quick. But all you're going to be doing is multiplying by 180 over pi and then making sure that you are not missing your units anywhere. That's probably the most important part. Also, if you're having trouble with a calculator, one of the easiest ways to do that is just to refresh it. So if it's giving you some trouble, go ahead and refresh it. That'll usually do the trick here. Okay? Alrighty. Hopefully that wasn't too fast. If you have any questions, of course, email me, message me on Teams, etc., etc. There are a million ways to reach me. I am more than happy to help. All right, coterminal angles. So from here, we're going to start with the definition of a coterminal angle. So it's two angles in the same standard position on the unit circle. You can find coterminal angles by adding or subtracting 360 degrees. All right, so I'm going to do this example down here, all right, because I want y'all to see what exactly we're talking about here, okay? So unit circle, by definition, just it's a circle with a radius of 1 who's centered at the origin, okay? And from here, right, remember how we were talking about earlier about when we did quadrants? We start an angle off right here, right? So this is the one side of the angle. And then for 110, right? This is 90. 110 is probably a little bit over that, right? 20 degrees or so. This is 110, right? And what we're talking about is 110 is this angle right here, 110 degrees, right? All right. So a coterminal angle means that we either add or subtract 360 degrees, right? So here, obviously, 250 is negative, so it's probably minus 360, right? So let's think about negative. If this way is positive, this way is probably the negative, right? So the negative 250, right? So that's 90, 180, 270 is too far. So negative 250 is this right here, right? It goes to the same exact angle, but it is negative. It goes the other direction. See how that one went that way and the yellow went the other way? So that's your negative 250. That's this one right here. And how we got that number is just 250 is 110 minus 360 equals negative 250. Okay? Series, of course. You can also do this in radians, but we're only going to do it in degrees for the moment. All right. And then what about 470? 470, let's do that in, I don't know, purple. I feel like purple. All right. 470, let's think about it. So 470, we go around, right? This is, actually, I could actually draw it. All right. So 90, right? 180, 270, 360, but we're not done, right? So we're going to keep going. 360 plus another 90, which gets us to what? 250, and then, or not 250, 450, and then another 20 degrees. And then we end up back at that same angle again, right? But we just went around an extra time, all right? So it's coterminal because we end up at the same angle, right? And the reason how we get it is we just added 360 because 360 is one full circle. So, right, we went around one extra time and then we got to our angle, okay? So that's 110, which was our original angle, plus 360, okay? Equals 470. And if we wanted to do 830, right, that would be two rotations around. So 360, if you go around again, you get to 720, and then we get to 830. Does that make sense? So all we have to do for this is add and subtract 360, or add and subtract multiples of 360. So let's start with subtracting 360, right? And I'll do that in yellow because that's what we've been doing. All right, so 210 minus 360, right? That gives us, if we were going to use a calculator, which I suggest you do, 210 minus 360 is negative 150, right? And don't forget your units, which are degrees, right? Units in the final answer. It doesn't matter so much in your work, okay? Or for instance, if we wanted to add, right, 360, we could do 210 plus 360, right? And that would give us a coterminal angle of, go ahead and type that in. You can use your keyboard to write these out. I hate typing on the calculator keypad with my mouse. All right, and we get 570 degrees. All right. But what if we wanted to get some more coterminal angles, right? Because there's infinite answers for this, right? Infinite answers. So for instance, I could do, let me pick a different color. I could do 210, right? Minus 360, and then subtract 360 again if I wanted to, right? And so if I did that, right? Because you're just subtracting two rotations. It's still okay as long as you're adding and subtracting 360. And that would give us negative 510 degrees, right? Or if I wanted to do it with adding another 360, right? I could do 210 plus 360 plus 360, right? And that would get me plus 360 plus 360 gets me 930, right? So the moral of the story is there are infinite things. You could add 360 again. You could subtract 360 again, right? So I could do 210 plus 360 plus 360 plus 360, though at some point it gets a little bit extra at TBH. But so if I wanted to add another 360 to this, I could, right? 1290, right? It goes on and on forever. There are infinite answers here. But, you know, in order to keep your sanity, remember that it asked us for how many answers? Just two. So you really only need two of these, right? It's a beautiful rainbow and all, but only need two, all right? You can do these in as many different ways as you want. So let's go ahead and try B together, and then I will leave the rest for y'all to do, all right? So B, right, we have 55, right? So let's start with minus 360, right? Probably the easiest one right here, all right? Negative 305, right? And I'm going to do a plus 360. Those are probably the most common ones that you're going to see, just adding and subtracting 360. But again, there are infinite answers. This would probably be structured as a quiz or a multiple choice question or a true or false question where I gave you two and I asked you which ones are coterminal or if they're coterminal, and you would just have to tell me. Okay, so you'd have to say, okay, yes, because I added 360 a couple of times and I got the next answer, right? So go ahead and do the rest of these. All right, I'm going to put up the answers really quick for you. Again, make sure you're showing your work. That's really important. If you don't show your work, of course, you won't get credit if it's not a multiple choice question. Um, and even if it is a multiple choice question, the reason I'm having y'all show work is because it's really hard to give you credit if you're all just copying each other's answers instead of doing it yourself. And that's the only way I could figure out to make sure you're actually doing your work. Okay. So I know it's kind of a pain sometimes to take pictures of your work, but that's the reason why. All right. Alrighty. Hopefully that worked well. Go ahead and check out the practice. If you want more practice on this, make sure you get your assignments in. Otherwise, I will see you in the next lesson. Have a good one, y'all. Bye bye.